The title of the research is the force and ambient vibration testing of structures, basically. I am Shanam Navai. I'm the interim chair of the Civil Engineering Department. I'm here together with Dr. Gustavo Maldonado, an associate professor in the department, as well as Dr. Bouillon, an assistant professor. The purpose of the research is to be able to determine the damage in the building due to dynamic loads. By dynamic loads, I mean wind loads, earthquake loads, as well as impact loads. We have already purchased several pieces of equipment to help us with this regard. We have already purchased 8 accelerometers and 1 data acquisition system. And what we are hoping to be able to get, and that's what we're trying to get now, is a shaker for exciting the buildings. Dr. Bouillon and Maldonado, they have already a good bit of experience in the area of dynamic analysis of buildings. Prior to coming to Georgia Southern, Dr. Maldonado was an earthquake engineer in California for 2 years in 1994 and 1995. And his job there was to acquire the data and process the data from the accelerometers in the field. And Dr. Bouillon, his studies was in Italy, France, and later on at Georgia Tech. And he has considerable amount of experience in dynamic testing of buildings. And prior to coming here, I think he was working on testing a 9-span bridge, I think around Atlanta in I-20. So I will pass it along to Dr. Gustavo and Bouillon to tell you a few more things regarding their project.
All right, thank you, Dr. Navai, for the introduction. And I would like to mention a few words related to the procedure that we plan to apply on this research. And basically, what we have here in this poster are instruments that we are going to use. The one that is over there is a sensor, a high-sensitive acceleration sensor, and we have the data acquisition system. What we plan to do is basically attach these sensors to buildings and also roadway bridges, like examples that we have here. And the main idea is to try to obtain data that will be able to, with that data, we'll be able to predict if the building has had some damage or some deterioration. So the main idea is the following. We are going to shake the building or the structure, say a bridge, and then with the sensor we collect the data, acceleration data, and then we post-process that data to obtain a spectral result. The spectral results are very important because they tell us the maximum amplitude of the structure at different frequencies. And every structure has natural frequencies that are directly associated to the stiffness of the structure. So if we measure that in 2 different time periods, let's say 1 year apart, and a bridge is deteriorating, and we measure one, make the measurement today, and then we make the measurement later, we can see with this instrument the different natural frequency of the structure, and we can see also the relationship between the frequency with the stiffness. If we see a change in the stiffness of the structure, then we can associate directly damage to that structure. So that is the main idea, to obtain identification of deterioration of the structures, in a few words.
We are going to use industry standard and research standard software such as SAP 2000, OpenSys, to model the structure like building, bridges, water tank, whatever it is. And what we are going to do is once we get the results from our testing, we are going to update our numerical model. Once we update the model, that means we have a realistic model of the building or bridges. When we get those realistic model, then we can evaluate the structure if that building or bridge can sustain hurricane or earthquake or impact loads. That is one benefit of the research. Now another benefit would be DUT is very interested what is the condition of their bridges, as they have thousands of bridges around the state. And now with the help of the instrument, we may able to evaluate the state of the bridge, whether that need retrofit or not. So in summary, with those instruments, it will be a great help to evaluate the structural health.